resoundingly, people said that they preferred in person, but tracking the numbers for, let's say, the last 2 years, we've gotten better participation via WebEx than we did in general in person. I kind of miss the in-persons, but we definitely get more people. But we do also have the nice thing that we folded in the Orange County group, but that's just very recent. So overall, it's been pretty good. So tonight, Michael Kim is going to be going over Cisco ISE and 802.1x. Michael is senior network engineer with my company, LA Networks, and he heads up our security operations practice. And just so you know, a little housekeeping for next month, we're going to keep it in the security family. And two people that Robert works with, AJ Shaw and, help me out, Robert, and
Ray. Was it Ray?
Ray Elkins, I think, are going to do, I think Ray's going to do Secure X, which is kind of a, it's kind of a management slash API sort of tool for your SOC. And then AJ is going to cover Stealth Watch and encrypted analytics. So we're going to keep it kind of nice and security focused this month and next. And then I think in December, we'll do a routing topic, kind of TBD, based on some things coming up. So I think we're going to end the year pretty strong with 3 really good topics here. And with that, I'm going to go ahead. Michael, can you, are you in a place where you can turn on your camera since we're recording especially? But
I do not have a camera. Sorry.
Do not have a camera. Okay.
No. They're sold out on Amazon.
Okay.
They have them on Costco this month.
I will turn it over to Michael to go over ISE and 802.1x.
All right. I'm just going to start sharing my screen. Okay. So it's the subject of this presentation is 802.1x with Radius and ISE. It's kind of a little bit 802.1x heavy, and then talks about kind of how you can leverage ISE to do all of the kind of authentications and authorizations. And give me one second. I'm going to actually push this chat box over. Let me know if there's any kind of gray box in your screen, or if there's anything that you guys aren't able to see. So I don't recall if this is what we normally leave in here, but I guess a little bit about LA Networks, founded in 1997, started, managed, and led by engineers. Our core technologies, managed services, collaboration, data center, network, security. I'm sure you guys have all heard this before. Just give me over that. Okay, so some of the new challenges that people are facing in networking, this has kind of been a challenge for a while, but it's kind of just continues to grow. It's maybe was a little bit more relevant maybe a year or two ago when everyone was still kind of in the office. The landscape has kind of changed recently with everyone working remotely, but for the most part, the changes that we were seeing was more kind of diversity of technologies on the network. So with that, you see kind of more emphasis on things like video, along with kind of older stuff like data and voice. More people bringing their own devices onto the network, more IoT devices, cameras, and things like that. Kind of making it difficult to manage, making it difficult to kind of see what's on your network and control what people were able to communicate with when they got onto the network. And then also recently, kind of the new focus or direction that people are going towards with security is kind of a zero trust architecture. What that means is because you have all these kind of new devices on your network, stuff you may not manage, just lots of devices that you may not be able to keep track of or inventory or patch, they came up with this architecture, which pretty much means that regardless of whether or not you own the device or you're aware of the device, or it's on your inside network or it's on the public intranet, you want to kind of consider everything as untrusted. So what that means is, as stuff plugs in, you want to find out what that device is. Is it owned or operated by who it says it is? And what should that device be able to communicate with, and what should it not be able to communicate with? Okay, so as part of that, kind of what people leverage to kind of do the authentication and authorization portion is 802.1x. So 802.1x is a method to authenticate devices connecting to the LAN or the wireless LAN. So although 802.1x is kind of defined as kind of the method, it leverages kind of EAP as its kind of authentication framework. So EAP defines kind of how the credentials and everything is packaged together. 802.1x defines kind of how that is delivered and used for authentication when you connect to the network. So EAP stands for Extensible Authentication Protocol. There are a few different kind of protocols for EAP. I'll go over that kind of in some additional slides. So, and then because EAP isn't really a kind of a wired protocol, it's kind of just a framework for how stuff should be packaged. 802.1x and also kind of Radius is what it uses as its transport mechanism. Sorry, I missed that question. Feel free to unmute yourself if you have a question, and just kind of lull if you just want to kind of pipe up and ask.
Hey, Michael, the question was, is this multi-tenant capable or licensed per network environment?
Are you talking about ISE specifically? So ISE technically just runs as a Radius service, so you can use it with multiple different environments. I'm not sure exactly if that was what you were asking.
Ray, do you want to elaborate on your question a little bit? If you can.
Multi-tenant meaning for different customers or different clients, like an MSP can use.
That I would not recommend. I guess theoretically I would think it'd be possible, but just because this is kind of meant to be, it doesn't really have multi-tenancy built into it. You can define kind of multiple identity sources to use, and I guess theoretically you could define policies to make it work that way, but you really shouldn't. So the answer is theoretically, but no, you should not try to do multi-tenancy with ISE. All right. Okay. So the main components of 802.1x, Radius and ISE. So 802.1x defines a supplicant running off of your endpoint, an authenticator, which is usually the network device, like a wireless LAN controller, and an authentication server. For our purposes, we're using kind of Cisco ISE as our authentication server. So what is a supplicant? So a supplicant in 802.1x is an application or process used to authenticate to a network using EAP and 802.1x. So some common supplicants that you normally see are kind of the built-in Windows supplicant. And if you use AnyConnect, there is a network access manager module that acts as a 802.1x supplicant also. So the supplicant kind of defines, at least on the endpoint side, what EAP methods and protocols to use, and kind of delivers that to the network device, which acts as the authenticator. So the authenticator accepts the EAP information, and ultimately it passes it on to the authentication server. The authenticator is usually also the device that kind of enforces the authorization policies that you receive later on from the authentication server. And like I said, commonly you'll see like on the switch that the endpoint's directly connected to, or the wireless LAN controller. How would terminals like WISE devices operate? Sorry, do you mind elaborating on what a WISE, WYSE device is?
Thin clients.
Oh, thin clients. So, so I can't speak for everyone's environment, but for us, we have thin clients running with certificates for authentication for .1x. For if they don't support an 802.1x supplicant, or you can't use like a username and password with that supplicant, what you can do is if you have kind of inventory of those devices with ISE and 802.1x, it can package kind of MAC addresses for authentication, and you can do authentication policies and authorization based off of MAC addresses. So you don't necessarily have to have the 802.1x supplicant running to authenticate devices that maybe don't support it with ISE.
Wouldn't it be possible for another device to replicate the MAC address?
That is possible. Yeah, there's some issues that's why normally when you do it, we would normally kind of prefer to use a certificate for authentication. That's kind of harder to replicate. It has a private key that someone would actually have to be able to kind of steal and copy. So yeah, if you ask me, certificate-based authentication is preferred, but if that's possible, or someone doesn't want to undertake it, MAC authentication bypass is also possible. All right.
Okay, thank you.
You're welcome. Okay, so here Cisco ISE acts as the authentication server. Sorry, I saw a question, but we still see them as MAB and ISE. So if you're running certificate-based authentication, so on the switch config, generally you specify an order that you want to attempt authentications for. So it should try to do .1x before it does any sort of MAC authentication bypass. And even if it does the MAC bypass, you still have to define a policy on the ISE side for how you would authorize that that device to be used on the network or what it can access. So if it's running .1x, we'll use .1x first. If it's using MAC authentication, that would happen after .1x. And if it's not something that's kind of defined in your endpoint groups, you can set up policies to pretty much block traffic or not allow that port to be authorized off of the switch. I don't know if that answered your question, but yeah, feel free to, I guess, ask in chat if it did not, or you can also unmute yourself to ask questions. That's fine also. Okay. All right. So so the Cisco ISE acts as the authentication server, kind of in our example. So really, it's just functioning as a radius server for .1x. There's kind of a multitude of things that ISE does other than just radius, but for .1x specifically, kind of radius is the main function. So the authentication server receives and responds to authentication requests, and then it performs the actual authentication and authorization and passes those down to the authenticator. All right, so kind of that brings us up to kind of our next question, which is kind of what is Radius? So Radius is the remote authentication dial-in user service. It's a client-server protocol, usually with a network access device acting as a client and a Radius server. It does authentication, authorization, and accounting. So unlike TACACS, the authentication and authorization are joined in Radius. If you guys have used kind of the old Cisco ACS, Cisco ISE is kind of like the next generation of that type of device. Which brings me to Cisco ISE. So Cisco ISE, like I said, was is a next generation radius server. So within Cisco ISE, you can actually do some inventorying. You can define and group endpoints by MAC address. It has kind of built-in profiling probes that you can use to kind of reach out to networks, see what's out there. It also can function as a certificate authority, so you can use it to give or pass out certificates and authenticate using itself as the actual authority. You can use kind of the endpoint authentication using 802.1x, NAB, for supplicants or for computers or endpoints that might not support 802.1x or that you might not know the MAC address for because it's not a device you manage. You can also do central web authentication for group access or things like BYOD. You can create policies for authentication. You can also create policies for authorization for those devices. Okay, and this is just kind of a, I just thought it was a pretty good kind of breakdown of what Cisco ISE can do. So on the left, you see kind of the different types of authentication methods it supports. What competitors to ISE are in the marketplace? Technically, because this is the Cisco users group, don't know if they want me to say specifically. If you ask me offline,
I think
can
that's
let you know
fine. Yeah, that's fine, Michael. You can.
Is it okay?
Yeah.
All right. There's
I mean,
the kind of, I guess the bigger one would be Path. I think that's probably kind of the biggest competitor. I'm sure there are others, but that's kind of like the other big one that I'm familiar with. All right. So kind of moving on. So on the kind of the top and the right, these are kind of the different identity stores that you can use with ISE. So yeah, you can use certificate authorities to do certificate-based authentication. You can do some external identity stores. You can actually also even use another external radius server to authenticate to. And then down at the bottom, the authentication methods that ISE supports and authorization options that ISE supports. So kind of bolded here are kind of the downloadable / named ACLs or DACLs and security group tags. Generally, I would say those are probably, DACLs are probably the most commonly used. Things like the VLAN assignments can have issues with certain types of IoT devices. URL redirection, normally for redirecting endpoints to a web authentication server or a portal for like your guest or BYOD, or even just devices for deployment or enrollment, things like that. So it's, I was trying to come up with kind of specific ideas for why you would use 802.1x and ISE. Basically, it comes down to, it's just a more secure method of controlling what can go onto your network. Kind of the granular manual approach would be control what plugs into where, show all your other interfaces, create access lists for each type of device on to every single switch, and assign them to interfaces that stuff moves, which isn't very scalable. People unplug things, people kind of move desks, plug into different places. So ISE kind of lets you simplify that as far as making sure your policies are being applied consistently and across your your entire switching environment, regardless of whether or not people are maybe moving desks or plugging things in that they shouldn't be, or someone malicious coming in and trying to plug something in to your network. Can the switching environment include Juniper, and Meraki? So Juniper, so everything is not Cisco proprietary or standardized at this point. So although I haven't done Cisco ISE with Juniper specifically. I'm pretty confident that Juniper and both Meraki will support. I know Meraki supports it, 802.1x, but I'm pretty confident Juniper will too. If Juniper doesn't support it, that's not necessarily something you'd maybe want on your enterprise network, but I know people do, so I'm pretty confident that it does. But I can't say for certain because I haven't actually deployed it on Juniper switches. But I'm gonna just answer yes for that. All right, so we've kind of talked about authentication versus authorization. So I'd like to just kind of define the difference between the two. So authentication pretty much boils down to who are you that's connecting, and can you prove that you are who you say you are? So that can be a certificate, that can be credentials, that could be MAC address, but like Charlie was saying before, MAC addresses can be spoofed. So the more secure methods would be name and certificate with EAP. And authorization. So what is authorization? Authorization is, are you allowed to do that? I'm telling you what you can and can't do, so I verify who you are. So after the endpoint authenticates, we kind of, as the authority for what you can and can't do on the network, we define policies that say you can go to this subnet or you can talk to this endpoint, but you can't talk to this subnet or this endpoint. And that happens on the kind of the access switching layer that the device is connected to. So you won't see it. So it'll stop that traffic as close to the source as possible, which will also tend to decrease kind of just bandwidth usage for non-allowed traffic on the rest of your switching environment. Okay. So this is a kind of just a flow chart of the authentication process. So I'm kind of going to talk through the kind of the process from start to finish. So the endpoint connects to the network. If the endpoint has a supplicant running, that supplicant, depending on how it's configured, will gather either your certificate assigned to maybe the machine or the user, maybe a username or password, or a token. So I'll kind of package that up into EAP. EAP will be packaged into 802.1x for transport across layer 2. So because it is across layer 2, this can actually, the authentication with EAP can actually occur before the actual endpoint gets an IP address. So before like DHCP even finishes. So it's not layer 3 dependent. It's it's a layer 2 authentication method. So the EAP over 802.1x gets delivered to the authenticator, in this case usually a switch. So that switch will take that EAP information and it will put it into another transport method that can go over layer 3. So if you have kind of normally on a switch, you would set up AAA server groups. So you have like a radius server IP that you point to, and the radius shared secret that's shared between the two that allows for like encrypted traffic to pass between each other. So the EAP packet will be packaged into radius, and it creates an access request packet, and that gets sent over to the authentication server. So the actual EAP communication between the endpoint and the authentication server, but it kind of gets packaged into 802.1x and radius as it makes its way from the endpoint to the authentication server itself. Okay. So once the authentication server gets the credential information from EAP, it'll authenticate that across to your identity store. In this example, it's using Active Directory. I don't recall the specifics. I think it uses either Kerberos or NTLM for Active Directory, but it can also do to LDAP servers. You can also do it to another external radius. If you're getting a certificate, it can actually just verify the certificate against the trusted certificate authority. And once the actual credentials are authenticated against, then it goes into authorization policies where it matches specific conditions. If it matches those conditions, it defines what the endpoint will ultimately be able to talk to. So it gets the authorization policy for that endpoint based off of the EAP data, gets the authorization profile, and it packages that up back into a radius packet, an access to step packet, along with kind of a EAP success packet, saying that the EAP authentication was successful. So that gets sent back over radius back to the authentication, from the authentication server to the authenticator, and then the authenticator will kind of repackage the EAP success to the endpoint to say that it did successfully authorize. And then the authorization profile information and policies gathered from the authentication server, that's actually applied, especially if it's like a DACL, it's applied on the authenticator level. So usually it'll take that DACL information, it'll see the actual interface that endpoint connected to, and it'll apply like a inbound ACL onto that interface. So the nice thing about the kind of this process is the actual downloadable ACL, it doesn't have to be predefined on the switch itself. For wireless LAN controls, the last time, if I recall correctly, you do actually have to kind of pre-program that into the wireless LAN controller. But as for the actual switches, you don't have to have the actual ACL existing on that switch. It'll actually be sent over with the radius, and it'll add that ACL into the switch for you and apply it to the interface. So you don't have to do anything manually to get that applied. And then once that process all goes through, the endpoint's authenticated and authorized, and it can get to wherever whatever resources that you say that it can get to based off your policies. All right, it's just kind of another kind of chart showing the kind of the back and forth for the authentication process. I just thought something interesting you guys can kind of look at. All right, so talking over the kind of the authorization options, I kind of talked a little bit about these before. So downloadable named ACL, airspace ACL, that should actually be, I think, AIRE space. I didn't create that picture, so you could do dynamic VLAN assignment, security group tags, which are becoming kind of pushed more as a more secure option. I didn't really go over the specifics for that. Sorry, Carly, can you repeat your question, please?
When it's being granted access to resources, does the resource connect go as high as the application, or is it limited to something lower down the stack?
For the DACL specifically, it's kind of lower down the stack.
It may not necessarily be the DACL, but for the process as a whole. I believe this is kind of more for the access layer, so it'd be kind of more IP and port based. For security group tags, I think you have more kind of freedom, but that honestly I would have to kind of specifically look into. I haven't done any kind of real security group tag based deployments, but I think for that you can get more application layer based. But yeah, I'll look that up for you and I'll kind of get back to you and give you that information. But yeah, Thank you.
For our example here, you're welcome. For our example, it's mainly kind of just up to layer 3, just based off the IP address and port. One thing for the it's pretty much just IP layer. All right, so this is just kind of an example of what the authorization looks like. This is just kind of I just took some screenshots off of ISE. When the DAC was applied, so I think I caught that question. So I think the question was, when the DAC gets applied, is it applied immediately to the interface? So I don't have a switch to actually kind of demonstrate across, but at least on Cisco switches, there's actually a command you can run as the authentication takes place. It's like a show authentication session, I believe interface, and then you can define the interface and put detail. And it'll kind of show you the running process for how that .1x authentication comes through. Usually there'll be like kind of a waiting period while it does the authentication. But then once it comes back, you'll see that the DACL gets sent back and it's applied onto the kind of the interface immediately. Each DACL has kind of a random sequence generated, so they're all kind of unique to each one. So if for some reason a port goes down and that DACL goes away, it doesn't affect any other ports. But yeah, the DACL will be applied to the interface immediately. It won't be like after like a shut, no shut or anything like that. It's just authenticates and then gets applied. Okay, yeah, I think there were a couple examples that people put up in chat, and then also for NXOS, I think Yinggu, I hope I pronounced that correctly, says that it should be show access session on NXOS. Yeah, so this is just kind of examples. I'm going to kind of go over this again on the demo portion, just kind of how authorization policies and profiles are kind of specified, but this is mainly how it looks. You set up conditions for specific authorization policies and define an authorization profile that gets applied based off of those conditions. So now I'm going to exit out of here. So I actually have. So let me know if I need to make the font bigger or zoom in anymore. But this is just the decloud session. It's a little bit limited as far as kind of showing you everything on the switch. But I think it's kind of good for people to get familiar with ISE, be able to kind of see how the policies are kind of defined, be able to kind of mess around without doing like a production environment. You can also deploy ISE. I think some of the older versions that may still be available if you have a license, I believe they still have kind of a 90-day grace period where you can kind of play around with it. But if you have access to dcloud, I recommend using kind of dcloud if you want to just play around with the interface. Maybe just make some dummy policies just to kind of see how that would work. All right, so kind of just showing this one as an example. So we have our policy sets in ISE. So these are evaluated from the top down. So for the most part, here we have kind of wired and wireless map for guest access first. So if we're doing .1x, this won't get applied. This specific example kind of doesn't account for for IoT or phone map devices, but you can kind of imagine that normally if the policy on the actual authenticator is for .1x to be authenticated first, generally you put like map devices below. But as long as you kind of remember that that's evaluated from the top down, you can kind of set your policies however you want. So here we have the conditions for matching this specific policy. It's either wireless 802.1x or wired 802.1x. So kind of the nice thing is that for some of the more common conditions, these are kind of pre-built into their condition library. But if you had any specific conditions that you want to set yourself, you can actually save custom conditions and just have them saved. They're conditions you think you kind of use maybe multiple times with different like and or statements. Here, this is where you define kind of the EAP protocols or methods that you actually support. So this has to match across both your applicant, your authentication server. So in this case, this is actually it's just a name, so don't kind of just trust the name. You'd actually want to, for the most part, unless you built it yourself, check what the actual methods being allowed are. Here, if you want to kind of see what that is, or if you want to create like a new allowed method, usually I just go to Work Center, policy elements, and then the results, allowed protocols. There's different ways to get to it. That's just kind of how I first found it and what I got used to. So if we go here, we can see what we are allowing for that specific EAP methods for that specific authentication or policy set. So we're allowing EAP-TLS. So for EAP-TLS, that is for certificate-based authentications. We are also allowing PEAP. So PEAP stands for pretty much protected EAP. It's kind of an encrypted tunneling method. It consists of an outer method, which is kind of the tunnel, and then an inner method, which is usually just another EAP protocol that you're kind of passing through that protected tunnel. So here we're allowing for PEAP, and our inner methods are EAP MS chat v2. That's usually your username password, and we're also allowing for certificate authentication within PEAP. Here it looks like we're also allowing TEAP. I believe TEAP is tunneled EAP. I don't recall the specific differences between the two. I think tunneled EAP may use a certificate for the TLS encryption, while I think protected uses, I believe, has a method for sharing like sharing a key prior to producing the tunnel. If anybody's interested in kind of the specifics, just let me know. I'll look it up for you, but I believe that's the case. Okay, so we have our condition set for our policy here. We have the methods or EAP methods that we want to allow. So if we click on this little arrow here, we go to kind of the actual meat of the policy. We go to how we want to authenticate devices and the authorization rules we want to apply to devices. So for here, we have the authentication policies. Right now, we just have a default, but you can actually set multiple conditions. Just like the condition set here, it goes from the top down. Usually, for something like this, it would be for maybe something like guest network, where even if it's not part of one of your identity stores, maybe you still want to be able to pass that along to the authorization portion, even though it fails the authentication. For anything kind of corporate that has either certificate or username password, you wouldn't really need this portion. But those are all kind of design choices that you'd have to consider depending on what you need your radius and ICE to do. So here we see the identity store sequence or the identity store that we're using for our authentication policy. Here we're using AD_ only. So this can actually include kind of internal endpoints, which is endpoints defined into ICE. They can include, I think, things like BYOD or stuff you enroll into your ICE. You can also actually define users in ICE's kind of built-in identity store. Guest users for guest access, those are enrolled, and depending on how you want to do it, you can create guest user accounts, which are temporary accounts that people can specify. AD1, this one here is actually the specific Active Directory that's this specific ICE node has been joined to. And then there's additional things like certificate request. All user ID stores is pretty much everything AD and your internal ID stores. For this one here, it's set to AD only. So if we want to kind of dive into what that actually means, we can go to Work Center and go to Identities. That one should be an identity source sequence. So these define what identity source to use and then the order to use them in. So for AD only, it's actually defined to use certificate-based authentication. This is a certificate authentication profile. I'll show you that afterwards. But then if this does not authenticate, it's configured to use your Active Directory store to authenticate. All right. So let's see. We go to sorry, I lost my train of thought for a sec. Okay, yeah, it's certificate authentication profile, which I believe that should be in policy elements. Yeah. Sorry, I'll come back to that one in a second. Let me show you actually the AD source group first. Oh, it's in the same area. Sorry. This is a certificate authentication profile. It pretty much defines, you can define like an identity store you want to use. So if you have kind of a PKI environment where your certificates are signed by maybe your domain controller that's also acting as a certificate authority, you can choose the identity store here. And then you can also specify where you want to get kind of the username to be pulled from on the certificate. You can also use Active Directory as an identity store. So the way this works is that you actually join the ISE node to the domain, just using kind of a username and password from the domain, and it just joins and it can do the queries and everything. I believe if you want to test, you have an option for different authentication types. But yeah, it's mainly the function is just to kind of join the ISE node to the domain. So if you actually go to your domain controller, you should actually see the ISE node under, I believe, domain computers after it's been added. All right, so that defines kind of how we're authenticating points for our policy. So now we want to go to authorization. So authorization, kind of like everything else in ISE, is based off of conditions. So after you authenticate, it kind of goes down the list from the top, finds a condition that matches. Usually you'll do something like the authentication type it's using, maybe the AD group that the endpoint, the username that the endpoint passed along belongs to. And then based off of that, you define an authorization profile. So this is what defines what radius attributes are passed down to the authenticator once the specific authorization policy is chosen. So for this one, we're using tier 1. Actually, let's do this one here. This is checking that it's wired 802.1x. It's checking if it's part of an AD group, probably called tier 1. And if it matches that, it's assigning this authorization profile. If we just go to policy elements and then results, under authorization, under authorization profiles, if we scroll down to tier 1 wired access, here you can define the access type. So here we're saying access accept. So we're saying authenticate that device. You can do things like access reject, and it'll kind of reject the authentication, but you probably won't really ever have to use that. So access accept, and then here we specify a DACL to be sent back as an attribute. And then if you scroll down all the way to the bottom, it gives you information about the radius attributes that are sent back. And And then if you want to see how the DACL is configured, you can go here. The one we were looking at was Tier 1 access. So it's not exactly the same as how you would maybe configure on a switch, but it's pretty straightforward, and there's always kind of an option here to check the DACL syntax. I don't know that this will be 100% kind of correct every single time. There are ways to kind of minimize impact when you're kind of testing out .1x. You can do it in kind of like low impact mode. You can do it for specific test interfaces only, or specific test endpoints. So I would say kind of test everything first before you kind of do wide scale deployments, if you happen to have to do any sort of .1x sort of implementation. So kind of the final, oh yes, you can add remarks to any of the DACLs. I believe it's still just like remark like on a switch, and then you could add comments. So if this is your server net, subnet, you could do like remark deny server subnet. The one thing is that the remarks will show up here, but I know that for some switches, the actual remarks or comments won't appear on the switch itself. So like you won't be able to see like the common information on the DACL after it gets applied. To kind of see what everything was for, you actually have to come back into ISE and check the DACL for all of your comments. All right. So kind of the last portion, but not really, is to kind of define your Radius clients. So because Radius is kind of a server client information, and there's a shared secret that has to be configured on both and match on both, you have to add the network device here. I'm just going to look at switches. So you can specify this for subnets. And I believe you can also, if you want to do a default, you can do a default just with kind of like a broad IP and mask. So you can set device profile, set radius, set the shared secret. If you want to use DTLS, you can also specify that here. So ISE also can do TACX functions. I didn't really go over that here, but if you ever do decline, you'll kind of want to see how TACX works and the types of policies you can set. Under work centers, there's kind of a section here for device administration. It works similarly. You have a policy set and conditions and specific authorization shells and command sets for device administration. All right, so for example, here we have our policy set defined. We've defined our authentication policy. We've defined kind of our authorization policies and profiles that we want to pass down. So kind of from, I guess, kind of like an overview from start to finish. Go back to my presentation really quickly here. So yeah, so you have your endpoint. It connects to the network, gets the certificate or username, password, or token, puts it into EAP. EAP gets tunneled into 802.1x to pass to the network authenticator over layer 2. Layer 2, the network device takes that EAP information, packages it into a radius request with that type of access request, sends it to your authentication server, which is our ISE here. So once ISE gets that EAP request, first it checks to make sure that it's a valid Radius client. But once that's confirmed, it goes through and starts checking through the policy set, chooses the first one that matches the conditions and the allowed protocols, checks the credentials passed along in EAP, makes sure it passes authentication. If the authentication fails, it'll reject it, send back like access reject. If the user is not found, it'll send back an access reject. If process fails, it'll drop and it'll time out and force the kind of the supplicant to re-authenticate. So assuming that authentication was successful, it'll go into the authorization policies. The same thing, start from the top, find the first one where the condition matches. Once the condition, match condition is found, it'll take the authorization profile here, and based off of the attributes defined in the authorization profile, it'll package that back up in a radius access accept message back down to the authenticator, along with the EAP success packet. The authenticator passes the EAP success to the endpoint supplicant saying you successfully logged in, so it doesn't do anything like tries to re-authenticate or anything like that. The radius attributes that are in the access accept packet, it uses that to define the kind of the access layer interface DACL and policies onto the actual interface pointing to the endpoint, which defines what that end is able to reach and what it's not able to reach. And it's not shown here, but you can follow along with kind of the process under the Radius live logs. There will be kind of a report area where you can see what policy set it hit, what authentication policy it went through, whether it was successful or not, what authorization policy it ultimately decided to use, and the authorization profile that was sent. And then on the report, there'll also be information about the radius attributes that were actually sent over. So you can use this to troubleshoot, see if someone's being kind of misprofiled or the policy is incorrect, if it's not authenticating correctly. This is generally where you would go to for your first step in troubleshooting anything radius related with ISE. All right, so that is it for kind of what I have to kind of show. Does anyone have any questions?
So does the authentication and authorization function happen at the same time?
Yes. So for Radius, the authentication and authorization is kind of bundled together. It doesn't send them separately. So when you get the Radius packet that the authentication was successful, you also get kind of all of the authorization rules along with it. So there are occasions or instances where maybe based off a policy, maybe you want to authenticate the computer first using kind of, say you have like user certificates and computer certificates deployed on those machines. So there are kind of policies that you can set where first when the computer plugs into the network before like a user even logs in, you have kind of that machine-based authentication go through, and that'll define policies that are set for that machine. So it'll still let kind of users when they log in to still kind of be able to get to some of the things that they need to get to, like DNS or DHCP and the domain controllers to log in. But once the user logs in, especially for like a Windows supplicant, it's kind of built in a way where it'll actually send out another EAP or .1x packet back to the authenticator for that user login. And if you define the policies correctly in ISE to kind of re-authenticate when that new user certificate comes in, you can kind of do like a change of authorization or send out a new DACL and get policy specific to that user reapplied. So it's not using those machine-specific policies anymore. You've passed over or sent out like the user-specific policies once that user logs in. So if you are using it, the one kind of caveat I would kind of say is the Windows built-in supplicant doesn't work with remote desktop. So if you kind of RDP into machine, it won't generate the user login 802.1x event. So it'll still kind of continue to use the machine authentication. Kind of a workaround for that is if you have AnyConnect configured and it's using that network access manager module, that one should re-authenticate with the user information instead of the machine. So that's kind of a lot of extra information, I guess, for what you asked, but yeah.
How are the policies processed? Is it top down, or when the condition is met, it just drops from there, or it continues executing?
It goes top down, so
Top down.
it should be the first condition matched. I know a couple other questions came in on chat. Let's see. First one: what happens when ICE fails and failover fails? The network devices are not able to find AAA. So for any sort of deployment, you'd want to kind of use HA or high availability. I don't know. I haven't really had a chance to go over ICE 3.0 yet, so I don't know if some things have changed. But depending on the number of kind of ICE policy nodes that you have deployed, there may be some kind of manual failover that you have to apply. If anybody kind of out there knows maybe a more direct answer, feel free to answer. But if authentication fails and all of your ICE nodes are down and you can't fail over, and all the authentications are failing, that's a very, very, very bad scenario to be in. I would say in that case, your best bet would be you'd have to maybe do a change. Maybe like an interface range command and just change the port authentication mode to open at that time, because that's kind of like a major failure. Hopefully, if you've kind of designed ICE correctly and if your partners defined everything correctly, you should have failover enabled. Yeah, all of that fails, you're kind of in a little bit of a tough spot.
In my organization, we found a really nasty bug in 2.4 that required us to come in really early one morning and turn off ICE on all of our switch ports. So it's bad when it doesn't work.
Logging? Yeah, was that the logging error? I forgot when that was.
I don't remember what issue it was. It was a while ago, but yeah, it was a very nasty surprise.
Yeah, it's ICE has kind of come a long way. Interface is better, everything's better, and they're kind of continuing to make changes. But yeah, kind of with something that touches so many different things and it's kind of very impactful. It's when stuff goes bad, it can kind of snowball really, really badly. And then does this change in 2.7? Was that regarding the Windows supplicant or?
It's about you can do in ICE 2.7. You can do user and machine authentication at the same time.
Is that the machine access restriction rules, or is that something?
Because prior to 2.7, I believe you cannot do Windows does not support the EAP training, right? So now I think Windows 10, and then I think it's the version 2004 and later. It actually supports the I think it's called TEAP. Basically just EAP training. So when they send the authentication request, it basically sends the user and machine all together. So I'm wondering if that will fix the remote desktop issue.
That is a good question. I have not tested that, so I don't know specifically, but that's maybe something that'd be interesting to do, maybe in like a lab, just to see exactly what the behavior is. I'd have to. It may be listed also in like maybe some of the release notes. Sometimes it's kind of a slog trying to kind of read through and remember everything, but that's something interesting. I'll try to check up on that, and I will. I don't know if I have your specific contact information, but I'll try to see if I can find that out.
Yeah, because right now we are on 2.6. I'm just trying to figure out if it's actually working. It's worth upgrading to 2.7 because that will help us solve a lot of issues.
Mm-hmm.
Thank you.
You're welcome. 2 users on 1 box. Which rule set would you apply? That is actually a switch configuration settings as far as, at least for like access switches. there's things like you can do single host where the first device that authenticates kind of anything else that maybe authenticates behind it would piggyback. You could do, there's things like multi-host. Multi-host is where it piggybacks. Single host is you only allow one. You can do things like multi-domain. I think the domains it really only counts for is the access VLAN and the voice VLAN. So you can have a device authenticate to each domain. And then you can also do multi-auth where each host that kind of connects to a switch port does separate each authentication to the authentication server. I don't recall specifically what that looks like as far as like what the switch config looks like, but that's multi-auth is what would allow for multiple guests. Anyone have any other questions?
All right, I think that may be it for the now. I'm going to go ahead and stop the recording. And